with the presentation of the METHODIST Advanced Skill Drills, modification of a box trainer to enable off-axis training in advanced laparoscopic surgery.
Good afternoon. I'd like to thank SAGES for this opportunity to present our work. My talk is titled MAD Skills, which stands for Methodist Advanced Drill Skills, modification of a box trainer to enable off-axis training in advanced laparoscopic surgery. I have no disclosures. The problem that we are addressing in this project is that current validated training platforms utilize only on-axis configuration of the camera and instruments. There is thus a gap in translating proficiency acquired in current training platforms to the off-axis setting as commonly encountered in advanced laparoscopic surgery. There is thus a need for a validated platform for off-axis training. Our hypothesis: we believe that learning to work in an off-axis setting is an acquired and teachable skill set, and that training to proficiency in a box trainer modified for this purpose may enhance intraoperative performance. We developed a box trainer for off-axis laparoscopic training. Our goal is to validate the results from testing several subjects, and then to finally disseminate the platform to surgical programs for senior residents, fellows, and attendings who have passed FLS. The MAD Skills box is essentially a standard box trainer which was modified to allow off-axis configuration of the instruments with respect to the camera. As seen here in the photograph, you see the abdominal wall. It has 8 stations labeled 1 to 8. Station 1 would be the neutral position as you would perform a task in FLS, and then going from stations 2 to 8, you are incrementally moving at 45 degrees from station 1. So when you're working at station 1, your instruments are on the left and right of the number 1. When you're at station 2, your instruments are on the left and right of number 2, and so on. So this video demonstrates a subject being tested on the advanced box trainer. As seen here, he's first starting out in the neutral position, and once he finishes, the box is rotated, and now he's at 45 degrees from station 1. And he continues to do that till he goes all around the circle from station 1 to 8. And this is moving to the next station, so on and so forth. So thus we have eight MAD angles of attack. So 0 degrees, 45 degrees, 90 degrees, 135 degrees, going from station 1 to station 4. And then coming around the circle, you have 180 degrees, which is station 5, station 6, 7, 8 respectively, and station 8 would be 45 degrees, again from station 1, but on the other side. So our methods: we invited 8 MIS-trained, FLS-certified surgeons to participate. I'd just like to remind you all this is still a preliminary baseline study we're doing at this time. Each subject performed 3 validated drills: the running string drill, which was first brought out by Dr. Rosser's Top Gun skills, which has now been incorporated by UT Southwestern; the pec transfer and intracorporeal suturing drills, which are under FLS. All subjects performed each of the 3 tasks as they moved from station 1 to 8 by rotating the box clockwise. Subjects were assessed with respect to time and accuracy as previously described for the UT Southwestern and FLS drills. A score of 0 was administered if the subjects were unable to complete the task. A cutoff time of 300 seconds was applied to the running strings drill and 600 seconds to the other 2 tasks. All performances were digitally recorded. Results are expressed as mean plus minus standard deviation. For task 1, looking at the time, going from station 1 to station 8, we see that at stations 4, 5, and 6, time significantly goes up and then comes down to a baseline by station 8. Similarly, when you look at the scores, which is the right-hand column, stations 4, 5, and 6 seem to challenge the expert surgeons the most as reflected by the lower scores. Similarly, at station 8, they start returning to baseline. Results for the pec transfer. Going from station 1 to 8, stations 4, 5, and 6 seems to task the surgeons more as reflected by higher performance times. And scores similarly go down at stations 4, 5, and 6. For intracorporeal suture, a similar result, starting from station 1, Going up to station 6, there's a gradual degradation of the result, coming closer to baseline as we reach station 8. And accuracy once again starts going down at station 4, 5, and 6. Our conclusions. The math skills drills challenge even the best surgeons as reflected in higher times and lower scores at stations 4, 5, and 6. These drills demonstrate potential for off-axis training in advanced laparoscopic surgery, and further work will establish construct and concurrent validity. I'd like to thank Dr. Duncan and Dr. Reardon, who are my mentors for this project, primarily Dr. Reardon, whose idea initiated the work. Thank you.